Julius Robert Oppenheimer, later known to the world simply as J. Robert Oppenheimer was born on April 22, 1904, in New York City. Raised in an upper-class Jewish household, he became widely recognized, not just for his scientific intellect, but also for the complex legacy he would leave behind. His father, Julius Oppenheimer, hailed from Hesse-Nassau, part of the newly unified German Empire at the time of his birth in 1871. Amid growing anti-Jewish sentiment in Europe, Julius emigrated to the United States in 1888 at the age of 17. Arriving with little, he carved out a successful career in the textile trade and had achieved substantial wealth by the time Robert was born. Robert's mother, Ella Friedman, was a New York native, born in 1870 to a family of German Jewish immigrants. An accomplished painter, Ella's artistic sensibilities had a lasting influence on Robert's worldview, especially in shaping his appreciation for beauty in science and nature. Robert had one younger brother, Frank, born in 1912, who also went on to become a physicist. The Oppenheimer family lived in comfort. By the 1910s, they had moved to an upscale residence on Manhattan's West 88th Street, overlooking Central Park. The apartment was adorned with original artworks by the likes of Van Gogh and Picasso, a testament to both their wealth and appreciation for culture. Robert's early education took place at prestigious institutions such as the Ethical Culture School and the Alcuin Preparatory School. His curiosity blossomed early. By age 5, he was already fascinated by minerals, a passion inspired by his grandfather. At 11, he was accepted into the Mineralogical Club of New York, an unusual accomplishment for someone so young. Academically gifted, Robert advanced quickly, completing 2 school grades in 1 year and finishing secondary school ahead of schedule. While he initially focused on mineralogy, his intellectual pursuits soon expanded to chemistry and then physics, a field that would become his life's work. In 1922, Oppenheimer enrolled at Harvard University at age 18. Though he started with chemistry, he transitioned to physics not long after. His early grounding in a broad array of subjects, including classical literature and history, gave him an intellectual versatility uncommon among his peers. He was particularly influenced by physicist Percy Bridgman, whose experimental approach left a deep impression. Oppenheimer's time at Harvard was marked by intense study. He often attended more classes than required and immersed himself in the university's vast library collections. Graduating in just 3 years in 1925 with top honors, he had already secured a place for graduate studies at Cambridge University in England. At Cambridge, he worked under the legendary Lord Ernest Rutherford, a pioneering figure in nuclear science. Oppenheimer's tenure there between 1925 and 1926 exposed him to groundbreaking research in atomic physics. By the end of his first year in England, he was invited by Max Born to study at the University of Göttingen in Germany, one of Europe's foremost centers for theoretical physics. It was here that Oppenheimer crossed paths with future scientific luminaries such as Werner Heisenberg, Enrico Fermi, and Edward Teller, many of whom he would later collaborate with on the Manhattan Project. In 1927, at just 23 years old, Oppenheimer earned his PhD. His defense impressed even his examiners. James Franck, a Nobel laureate, reportedly felt as though Oppenheimer might start quizzing him by the end. That same year, Oppenheimer and Max Born co-authored a pivotal paper that introduced what would become known as the Born-Oppenheimer approximation. This concept helped clarify the different behaviors of electrons and nuclei in molecular systems and became a fundamental principle in quantum chemistry. The scientific concept, later termed the Born-Oppenheimer approximation, emerged from the collaboration between Max Born and a promising young physicist with a deep interest in both chemistry and physics, J. Robert Oppenheimer. Their work demonstrated that the heavier atomic nuclei in a molecule remain relatively static, while the lighter electrons exhibit more dynamic movement due to their interactions with wave functions. This key insight allowed for a practical division of nuclear and electronic motion in molecular models, an essential development in quantum chemistry and molecular physics. Blending knowledge of chemical structure with an emerging understanding of theoretical physics, the approximation became a foundational element in the study of molecular dynamics and has had lasting value in the scientific community. Despite his academic brilliance, Oppenheimer was a complex figure. His personality was marked by a curious mix of intellectual aloofness and occasional sociability. Known for his heavy smoking, which ultimately contributed to his early death, he was remembered as both deeply thoughtful and at times unpredictably erratic. Former classmates and colleagues described him as someone whose brilliance was often coupled with emotional volatility and peculiar behavior. He was prone to overstatement and sometimes made questionable choices. During his time in academia, he sometimes clashed with others, and his behavior occasionally drew concern. One infamous incident during his stay at Cambridge involved him tampering with an apple left in a professor's office, an act that nearly led to his dismissal. Despite such episodes, Oppenheimer possessed a generous spirit toward students and collaborators. His eccentricity extended into his fascination with Eastern philosophy, particularly Hinduism and Confucianism. He even took the unusual step of learning Sanskrit to read sacred Hindu texts in their original language. This spiritual curiosity influenced his broader worldview, as he viewed scientific exploration as a pathway to uncovering deeper truths about the universe, not just as a means of gathering empirical data. Yet beneath his confident intellect, many biographers have observed a recurring theme of deep insecurity. As the son of a Jewish immigrant during an era of pervasive anti-Semitism, Oppenheimer often felt like an outsider. His inner conflicts, paired with periods of depression, made him an enigmatic presence among his peers. Following his studies in Europe and the publication of several academic papers, Oppenheimer returned to the United States. He briefly held fellowships at Harvard and Caltech, interspersed with short research stints in Europe, including time at Leiden in the Netherlands and Zurich in Switzerland, both of which were major hubs of scientific thought. It was in Leiden that he earned the nickname Oppie, a Dutch-influenced twist on his surname. By 1929, he had accepted faculty positions at both the University of California, Berkeley, and Caltech. For over a decade, he split his academic year between the two institutions, becoming a major influence on theoretical physics in America. Oppenheimer's unconventional and inspirational teaching style drew many of the era's brightest minds to study under him, particularly at the School of Theoretical Physics he founded. His seminars were renowned not only for their depth but for their philosophical richness. Outside of quantum mechanics and particle theory, Oppenheimer and his students would often engage in discussions on classical literature, ancient languages, and Eastern thought. Figures like Hans Bethe later remembered that Oppenheimer was so immersed in intellectual pursuits that he was largely unaware of major global events. For example, only learning about the 1929 stock market crash months after it had shaken the world. Throughout the 1930s, he and his students contributed significant developments in theoretical physics, establishing the foundations for the pivotal role he would later play in the atomic age. In the early 1930s, J. Robert Oppenheimer was already making waves in the world of theoretical physics. In 1930, he published research that pointed to the existence of a positively charged counterpart to the electron, what we now call the positron. Though he didn't directly observe it, this prediction paved the way for Carl Anderson, one of his associates at Caltech, to confirm the particle's existence 2 years later. Oppenheimer didn't stop there. He collaborated with physicist Wendell Furry to refine our understanding of the interactions between electrons and positrons, work that helped shape quantum electrodynamics. One of his most influential contributions came in 1935 with his student Melba Phillips.